Hello everyone, welcome to Math with Allison. Today we're continuing our series on derivatives. If you haven't already, make sure to check out some of my past videos. I have them linked in the corner. Click that little eye and it'll get you there. Otherwise, we're going to be going into the basic rules of derivatives and how those work. So let's go ahead and dive into it. I have the limit definition of a derivative written out here. So the limit as h approaches 0 of f of x plus h minus f of x all over h. And we know it's a derivative because of that little f prime. That's what denotes a derivative. So, question, are there any shortcuts to finding derivatives? There are, but we're going to take the long way to get there. So let's take our function f of x equals x squared. We want to go ahead and use the limit definition in order to solve for the derivative. So first what I'm going to do is plug in what I know. So I have the limit as h approaches 0, and I want to change my input from x to x plus h. So I'm just going to square that whole quantity minus the original squared all over h. So I want to go ahead and simplify that out. So here we always get to the point where things are going to cancel out. So my x squared and my minus x squared cancel out, and this is what I'm left with. So we want that h in the denominator to go away, and so we want it to divide out. I can do that by factoring an h out of the numerator. So I have the limit as h approaches 0. In the numerator, I pull an h out and I get 2x plus h. In the denominator, I still have that h. And so now I have that my h's divide out, and this is what I'm left with. So I want to go ahead and use direct substitution. I got rid of my issue, and now I can plug it in. So I get 2x plus 0, which is just equal to 2x. So now right here, my original function was x squared, and my derivative was 2x. I don't know if we see what happened here, but I took that exponent and I pulled it down. And this is an actual rule. So first we're going to talk about the power rule, which is what we have described here. When we take the derivative, we can also denote it as d dx. So the derivative in terms of our variable, and our variable is going to be x. So when I take the derivative of x to any power, that power comes down, and then I subtract 1 from the exponent. So when we did the long definition, I used the limit, I plugged everything in, I solved, or we can use the shortcut where I just bring that exponent down and I subtract 1 from the original exponent. So if I rewrote that, I get 2 times x to the power of 1. When we have a power of 1, we don't really need to write it, so I could just write this as 2x. So the point of rules is not for people to have to memorize them. It's just a shortcut because we don't want to have to write out the limit definition every single time in order to find a derivative. There's people who have already done that in the past, and so we're going to skip that hard work and we're just going to go straight to the rules. So it is a bit of memorization, but it's better than having to do the limit definition, right? So let's go over some other basic rules. Second, here we have the sum and difference. When we're taking the derivative of two separate functions, we can actually take the derivative of each of them individually. So remember, this little prime here means that we took the derivative, and also d dx also means derivative. They're just two different notations for the same thing. So it's kind of like the distributive property. We can distribute the derivative to both parts across the plus and the minus. So here we have an example, h of x equals x squared plus x cubed. If I want to find h prime of x, what I want to do is take the derivative of each one individually across the plus and the minus. So I'm going to take the derivative of x squared, which we already found to be 2x. Now let's take the derivative of x cubed. So with power rule, that exponent comes down, so I get 3x, and I subtract 1 from the original exponent. I'm going to rewrite this 2x plus 3 times x squared. And so that is our derivative, and that's how we can use sum and difference. Let's move on to our next rule. So we have the constant multiple rule. So our c just represents a number, and we have it times some kind of function. When we take the derivative of this, that means actually we can pull this c out. It doesn't make a difference, it's just hanging out there, and we can take the actual derivative of our function. So let's see what this looks like in action. I have g of x equals 4 times x to the 3 halves. So this right here is like our function, and our c is equal to 4. This means what I can do when I take the derivative is that 4 just hangs out here. It is chilling, it's along for the ride, and I'm going to apply power rule now when I take the derivative of x to the 3 halves. So I bring that exponent down, and now I subtract 1 from the original exponent. If we remember 3 halves minus 1, I can rewrite that minus 1 as 2 over 2, and so here I get 1 half. So now when I rewrite this, I get 4 times 3 over 2. But remember, these can divide out. And so this becomes a 2. And so now I can multiply straight across. And I get 2 times 3 is equal to 6, x to the 1 half. If you wanted to rewrite that with a square root, you totally could. So this becomes 6 times the square root of x. And that's how we can use constant multiple rule. So remember, constants, when they're being multiplied, they're just hanging out. They don't make a difference to the function. Finally, we have the constant rule, which is the derivative of some number c, and it's actually equal to 0. And we're wondering, why is it equal to 0? And I'm going to tell you why. So we have f of x is equal to 3. 3 is our constant here. But remember, we can rewrite 3 as 3 times 1. It's the same thing, right? But what if I told you I can rewrite 1 as x to the power of 0? Remember, anything raised to the power of 0 is equal to 1. So now if I want to find f prime of x, I can use the previous rule. So that 3 just hangs out, and now I'm going to use the power rule. So that 0 comes down, and I subtract 1 from the exponent. But when we multiply anything by 0, it makes the whole term equal to 0. And so we get 0. So that's the long way of doing it. The shortcut is that if we just have a constant all by itself, the derivative of a constant is always going to go to 0. Another rule we have here is the e rule. So this is the derivative of e to the power of x. And actually, the derivative of e to the power of x is just going to be itself. It doesn't change at all. There is a whole explanation for this. If you guys want to see the explanation, I can make a video about it, but you have to let me know. But we are going to go ahead and see all of these in action. So we have some examples here. F of x is equal to 3x to the power of 4 plus 7x plus 2x. So let's go ahead and use the rules that we know in order to find the derivative. So the first rule I know is that I can take the derivative of each one individually, which is very nice. Right here, I'm going to use constant multiple, so that 3 just hangs out, and now I'm going to use the power rule for x to the power of 4. So that 4 comes down, and I subtract 1 from the exponent. Now I'm going to move on to the next one. 7 times x, so that 7 hangs out. Now this has a secret little exponent of 1. So that 1 comes down, and now I have x to the 1 minus 1. Now moving on to the next term, we have 2 times that constant rule. And remember, the derivative of e to the x is just e to the x. So now we can go ahead and simplify this. So here I have 3 times 4 is equal to 12, and then x to the power of 3 plus 7 times 1, which is 7. But remember, this right here becomes x to the power of 0, which is equal to 1. And so that just remains 7. And now I get plus 2e to the x. And that is our entire derivative. Remember that you don't have to do each individual step. You don't have to write out 4 minus 1. You don't need to write out 1 minus 1. What you can do is go straight to this step right here if you want to do that in your head. If you like to see it written out, of course I suggest doing it, but you don't have to. There's no law that makes you. Here we have a new function. I guess I didn't name it, so we'll name it right now. Okay, g of t is equal to 4 times the square root of t minus 1/4 t to the power of 4 plus t plus 1. So let's go ahead and take the derivative of it. But before we do that, I'm going to rewrite it. So g of t is equal to 4 times t to the 1/2. The reason I rewrote that first term is because now I can see power rule in play. Minus 1/4 t to the power of 4 plus t plus 1. Let's go ahead and calculate the derivative. So g prime of t is equal to, okay, so that 4 is a constant, it's just hanging out. I'm going to leave it there. And now I can apply power rule to t to the 1/2. So that 1/2 comes down, and now I have 1/2 minus 1 because I have to subtract 1 from the exponent. Moving on to our next term, that 1/4 is just hanging out. I bring down the power of 4, and then I subtract 1 from the power. I'm just going to go straight to writing 3. Plus, and so now remember, if there's no exponent, there's a secret exponent of 1. I'm going to bring that 1 down, t to the 1 minus 1, which is equal to 0. And remember, the derivative of any constant, so this plus 1, goes to 0. Now, if I rewrote this, I get 4 times 1/2 is equal to 2. And now t to the 1/2 minus 1 becomes t to the negative 1/2. Now moving forward, I get 1/4 times 4 is equal to 1, t to the power of 3. Now t to the power of 0, that's just equal to 1. So now I get plus 1 times 1, which is just 1. And then this plus 0, I don't need to write plus 0, so it's just going to go away. We can simplify this one more time, actually, because this right here can be rewritten as 2 over the square root of t. Right here we have a negative exponent. When we have a negative exponent, we can bring it down to the other side, and then t to the 1/2 can be rewritten as the square root of t. So I get t over the square root of t minus t to the power of 3 plus 1. And this whole thing is my derivative. So that's all I have on the basic rules of derivatives. Make sure to stay tuned for the product rule, the quotient rule, and chain rule. Much more to go. But that's all I have for today. So if you enjoyed this video, please leave a thumbs up and comment other topics or problems or content you'd like to see done. Thank you for watching.